So today we're going to take a look at geometric sequences, day 2. So we're going to look at finding missing terms in a geometric sequence, finding how many terms are in a sequence, and we're going to find an introduction to series using the formula for geometric series. So first we're going to find the 3 geometric means between 12 and 3072. So similar to what we did with our arithmetic sequence, we set it up, we're missing 3 terms in between the 2 that we know. So we have the first term and the 5th term. Then we find the common ratio using our explicit formula, which remember was t sub n equals t sub 1 times r to the n minus 1 power. So I substitute what I know. We know the 5th term is 3072. The first term is 12. We don't know our common ratio, but we do know it's to the 5 minus 1 or 4th power. So when I solve this, I'm going to divide both sides by 12, which gives me 256 equals r to the 4th power. So remember, to cancel a 4th power, we take the 4th root. So there's 2 ways to do that on your calculator. You should have some sort of button that allows you to choose your root, or you can take 256 using a rational exponent to the 1/4 power, which gives us 4. So our common ratio is 4, and then we can use the recursive formula to fill in the missing terms. So 12 times 4 gives us 48. 48 times 4 gives us 192. 192 times 4 gives us 768. And if you want to just double check, 768 times 4 does give us 3072. All right, the next is to find a missing term within a sequence. Very similar to what we just did, the first thing we have to do is find the common ratio. So for those of you that are visual learners and want to see the sequence, you can start with t sub 4, t sub 5, term 6, 7, 8, and 9. So we know the 9th term, and we know the 4th term. So we have 4 missing terms. So this is going to be similar to what it looked like last time. So I'm going to call t sub 4 my first term, because I know that I am missing 1, 2, 3, 4, 5. I've multiplied by the common ratio 5 times. So I'm going to start with 45,927, and that will equal 189 times the common ratio to the 5th power, because again, there were 5 ratios that we multiplied by to get our last term. So solving it exactly the same way, dividing both sides by 189, I get 243 equals some number to the 5th power. So same thing, you can either take the 5th root, if you can find that on your calculator, or just raise it to the 1/5 power, and we get a common ratio of 3. So then we can use that to fill in the missing terms, and we only need 2 more terms to find the 6th term, because that's what we're looking for here. So 189 times 3 gives us 567. When we multiply that by 3, our 6th term was 1701. All right, so now we're going to use the recursive and explicit formulas to write an equation for our sequence. So the recursive formula, remember, is when it explicitly tells you what the first term is for, and then you find the next term based on the common ratio, which as we're looking, we're multiplying by 3. So it's 3 times the previous term, which is t sub n minus 1. The explicit formula would be allowing us to jump to any term in the sequence, whereas the recursive, you have to use the previous term. So we take the first term, let me write this out in case you guys can't remember. So it would be t sub 1 times r to the n minus 1 power. So t sub n would equal 4 times our common ratio of 3 to the n minus 1 power. Okay, so now we're going to take a look at series. So that was it for sequences. We're jumping into series just a little bit. And here's the formula for the sum of the terms in a geometric sequence. So the sum of the first n terms equals your first term. Notice that's not inside the parentheses at all. So be careful with order of operations on this one. And then you take 1 minus your ratio to the nth power. So again, that's the number of terms that you're adding, divided by 1 minus the common ratio. So let's look at a few examples using our formula. Actually, just one. This is our last example. And I wrote the formula down again here because I didn't trust my own memory. So I can refer to that. So we're given the first 5 terms. What is the sum? So we need our first term, which is 2. So I'm identifying all these pieces that we need for our formula. We need the common ratio, which in this case we're multiplying by 2. And then we need n, the number of terms, and we're adding 5 terms. So we substitute these into our formula. So s sub 5 equals our first term times the quantity 1 minus 2, our common ratio, to the 5th power over 1 minus 2. So you can just type this into your calculator. But be careful again with those parentheses that you're getting everything correct with your order of operations. And I got a sum of 62. And we could double check that by adding the terms in our formula. So we got 2 plus 4 gives us 6, plus 8 gives us 14, plus 16 gives us 30, plus 32 gives us 62. So it checks out.